Good day. I am Cadet Aviara Victor Joseph. So we're the first group. Our topic is all about the marine compass and magnetic variations. So course outcome: to determine the marine compass, magnetic variations, and correcting of variations. Learning outcomes: at the end of these sessions, the students should be able to correct the variations, know the marine compass and magnetic variations. Importance of the topic: to understand the marine compass, magnetic variations, and correcting the variations. Marine compass. In China, compasses has been used since the Han Dynasty, 2nd century before Christ and 2nd century Christ era. When they were referred to as south pointers, however, at the first these magnetic were only employed for geomancy, much like Feng Shui. Eventually, during the Song Dynasty, 1000 CE, many trading ships were then able to sail as far as Saudi Arabia, applying compasses for actual marine navigations. As a direct result, between 1405 and 1433, Emperor Chutis, treasure felt of the Dragon Throne, ruled the entire South Pacific and the Indian Oceans, a territory that ranges from Korea and Japan to the east coast of Africa. At this time, Western mariners were still rather incognizant of the navigational applications of the magnet. The first treatise on the magnet itself was written by Petrus Peregrinus de Maricourt, De Magneti, 1269, and through its nautical use was already mentioned in 1187 by English monk Alexander Neckham. The use on board only came about around the 13th and 14th centuries in the Mediterranean Sea. In 1545, Pedro de Medina, Sevilla, 1493 to 1567, wrote the Spaniard standards work Arte de Navegar on marine compass navigation. This masterpiece was first translated in Dutch 1580 and was irony put into practice by Jacob van Heemskerk when the Dutch destroyed the Spaniard fleet near Gibraltar in 1607. A drawback obviously was on Van Heemskerk on death during this victory.
Magnetic variation is the angle between the magnetic and geographic meridians at any place, expressed in degrees and minutes, east or west, to indicate the direction of magnetic north from true north. Variation changes dramatically around the world. Consequently, we need to know how to calculate the difference between this and true north. We can only plot true headings on navigational charts, as these are orientated to the fixed point of true north. Due to the fact it is always changing, so we need a simple tool to help us remember which way to calculate it.
So, the magnetic observation made by the explorer in subsequent decades showed, however, that these suggestions were true. But it took in the early 19th century to pinpoint the magnetic North Pole somewhere in Arctic Canada, 78 degrees north, 104 degrees west. And then from on the angle between the true north and the magnetic north could be precisely corrected. The the correction angle is called magnetic variation or magnetic declination. It is believed that the Earth's magnetic field is produced by electrical current that originate in the hot liquid outer core of the rotating Earth. This is the reason why magnetic compasses does not exactly point north. The flow of electric current in this core is continually changing, so the magnetic field produced by those current also changes. This means that at the surface of the Earth, both the strength and direction of magnetic field will vary over the years. The gradual change is called secular variation of the magnetic field. Therefore, the encountered magnetic variation not only changes with location but also varies over time. The correction of the magnetic variation for your location is shown on the nearest nautical chart compass rose. In this example, we find a variation of 4 degrees 5 minutes west in 2009 with an indicated annual correction of 0 degrees 08 minutes east. Hence, in 2011, this variation is estimated to be 3 degrees 59 minutes, almost 4 degrees west. And for 2020, the estimated is 2 degrees 47 minutes west. This means that if we sail 90 degrees on the chart, the true course, the steering compass would read 94 degrees in 2009 and almost 93 degrees in 2020. Note that true course is often shown as COG or course over ground or CMG, course made good, on your GPS plotter. Another example, let's say the compass rose on the nautical chart gives a variation of 2 degrees 50 minutes east in 2019 with a correction of 0 degrees 04 minutes east per year. In 2021, this variation is estimated to be 2 degrees 58 minutes, nearly 3 degrees east. If we sail 90 degrees on the chart, the steering compass would read 87 degrees. A pair of digitalized nautical chart can be featured multiple compass rose. Use the nearest one to obtain the magnetic variation.
So this picture shows us on how to correct for variation. The overlaid compass roses on the right illustrate the difference between true north hand magnetic north when the magnetic variation is 10 degrees west from the image we find true course equals CC plus variation, in which CC and TC stand for compass course and true course, respectively. To convert a true course into a compass course, we need first assign to a western and to an eastern variation. Note that this makes sense because of the clockwise direction of the compass rose. Here, the inner circle is turned 10 degrees anti-clockwise. Hence, negative 10 degrees CC equals TC, or compass course equals true course minus variation. 235 degrees equals 225 degrees minus open parenthesis negative 10 degrees close parenthesis. So to sail a true course of 225 degrees, the helmsman has to steer a compass course of 235 degrees. To convert a compass course into a true course, we can use the original equation. If we have steered a compass course of 200 degrees, we have to plot a true course of 203 degrees. In the chart, if the variation is 3 degrees east or a true course of 190 degrees, if the variation is 10 degrees west. So that's all our report. Thank you for listening.